Alrighty, good morning everybody. This is ONOS TST meeting. The meeting is public and recorded. Today we're going to kind of use the kind of typical fill-in topic, which is µONOS update, because the project's moving forward very, very quickly. Specifically today, will be update on Atomic's CLI, including demos, demos of the coverage reports from the CI build. We've also started to put together a consolidated CLI for ONOS config. Rai will also provide a simple demo of a simple end-to-end test script. We'll demonstrate Stratum integration. I think Andrea will be doing that, if I'm not mistaken. And then Adib will show some of the new features of the GNMI simulator. So we'll kind of mix the update and what was done and demonstration of what was done with each of those particular topics. So I think with that, we can probably hand it over to Jordan if you're ready.
Actually, I'm having some technical difficulties. Can we just reorganize a little bit?
Sounds good. So maybe Ray, can we move two of your topics together? So maybe Ray will do the coverage.
Well, the end-to-end test script, there's nothing new to show. It doesn't actually work right now due to other problems. But I can show the coverage and CI in general, actually.
Sounds great. So I'll make you a presenter.
Okay, let me see. What we got here? Sure. All right, so we, as people may or may not be aware, for this project, we've moved away from the sort of Garrett Jenkins model to do everything in the GitHub ecosystem. And one of the neat things about that is that there's just a bunch of stuff that's available for projects that are already hosted on GitHub. If you already have a GitHub account, there we go. You can get things like CI tools available to you without having to set anything up. They're free. They use this API that GitHub has called webhooks, where they sort of notify various applications of changes. And since the code is all public, these tools will just pull your code down and do interesting stuff with them. So one of the things we did was we set up this thing called Coveralls, dumb name, but it's a very useful tool. It's a coverage tool for various languages, does support Go. So the way this works is whenever a merge commit happens, let's see if I can make this a little bigger so people can see it. Whenever a merge commit happens, so you can see here, this was a change that was committed by Sean. This will trigger a build job on the Coveralls server, which will run all of our unit tests, collect coverage data, and then produce these neat charts for us. So the first line up at the top here, this sort of pinkish, orangish color that says 83%, that is just lines of code. So you can see that's up and to the right as you would expect on our new project. There's a little badge here to the right, which is also on our documentation page, which says our current coverage is 83%. That's actually not accurate. I wish it was 83%, but it's actually quite a bit lower. I have to fix some things to make that work. But, and the other thing that we can see, Thomas, do you understand this graph? I don't understand what this graph is telling us, the gray versus the pink. I think the gray is total lines of code. I don't know what the pink is.
I think it's the covered lines, right?
Is it? So it's 0 now? I don't know. Anyway.
No. So the graph, I'm sorry. I think the graph is not based at 0.
Oh, it's
hits per line, is it?
I'm sorry, go ahead.
Go ahead, Sean.
It says at the bottom right there, 6.99 hits per line. Is that what what it's representing?
I think the number of lines that is covered with the test case.
So I don't think I don't think the code captures 0. Basically, it's a narrow band that shows you basically the variation around the values that we have. The 0 is not shown.
Oh.
This is not based at 0.
Okay.
Because otherwise it would look without, you wouldn't see detail. Because it's been fluctuating by
very small
amounts.
Okay, gotcha.
Otherwise you would have a flat line.
Okay. The other interesting thing is, so you can see here up here, it's under PKG. That's where all of our code lives that we care about. If you expand this out, it shows you per package. So this is a nice way to tell kind of where your coverage is good and where it's not as good. You can do what you'd expect. You can drill into these and see like where particular file coverage is. This is similar to what Sonar does, but it's quite a bit easier to set up. The other thing that I really like is that it tracks you over time. And you can actually set, so like here, this one, we went from 80.58 to 83.37. You can actually set triggers that will fail your builds if the variation becomes too much. So if someone dumps a whole bunch of untested code in the repository, we can actually set this up to trigger that as a CI failure. See all builds. This is the other interesting bit, is not only does it do these merge builds I talked about, but it also does them for every PR. So for example, you can see Sean checked in this PR here. It actually ran coverage on that data set, on that change set. So one of the things that reviewers can look at if they're looking at a PR is they can look at what's the coverage on the new code, and they can make suggestions about things that should be done for testing. The other thing I wanted to just very briefly show is we have currently 3 things we're doing as CI. We do the normal Travis stuff that we already talked about, where we basically run the build and run all the tests to make sure we don't have any breakages. We have the coverage thing I just showed you, and we also have jobs set up on Docker Hub. Now what these do is on Docker Hub, you'll see, for example, under ONOS config, which is sort of the main one. If we go under tags, no, that's a bad choice. Let's go under the simulator. You'll see there's 2 tags there, one called stable and one called latest. Stable is the one that we've kind of agreed is a good one, and I build those and push them by hand. Those have sort of, that's the one we're currently supporting. Latest is built off of master every time there's a check-in. So the main reason for latest's existence is to make sure that the Docker infrastructure has not been broken as part of a check-in. So this is sort of CI for the Docker side of things. So that's what I wanted to show everybody. Anyone have any questions?
Ray, so is that a check-in on masters? Like something's been, pull request has been merged?
It's only on merge, yeah. The GitHub stuff runs on merge. So it's not ideal because it will tell you of a break after the fact. I don't know how to set it up to do it on PRs.
Okay. Okay. Yeah, no, just I wanted to be clear.
And you can see similarly here, if you go to the builds tab, you can see kind of these are all the builds that have been going for every check-in.
Yes. Yeah. Okay. The other thing I had was on the Coveralls stuff. It's the wrong guys getting the credit or the blame there on those commits. That was actually Andrea did all the work, and I was just the one that pressed the button to merge. So if there was,
I see. So it's
if there was a way of changing that, that would be maybe more fair.
Oh, that is interesting. So it gives credit, quote unquote, to the person who did the commit.
Yes.
As opposed to the person who did the.
I think it's 2 tabs left of your current tab there, but it's oh, yeah. Yeah. So basically, if there's any way around that, you know, it might be.
Oh yeah, and it literally does bitter. So the ones that say Webflow, those I think are the PRs.
Okay.
Because you see, it's got the pull number next to it, and these are actually live links. I'm not going to click on it now, but you can actually go right into the patch set on
into the pull request. Yeah, yeah.
I wouldn't worry about it too much as long as it knows what goes up, what goes down.
Yep. And the reason it's not accurate is because for whatever reason, since it's a tool that's looking at Go and everything in Go is package based, if you have no tests exists in a package, the tool doesn't even know that the package exists, and so it doesn't count 0 covered package lines against you, which I think is the wrong behavior. But I think we will probably fix this by checking in minimal tests for every package. That will force coverage information in, and then we'll get a more accurate number.
Thanks, Ray. This is great.
You're welcome. Do I have to relinquish control, or can you do that?
I can do that. So, Jordan, are you ready, or do you want me to go first?
I'm ready.
Ready. Okay. So I'll pass the control to you.
All right. So yeah. So what I've been working on since last ESP meeting was. So basically, I've been working on the deployment of atomics inside of Kubernetes. Well, a few things: the deployment of atomics inside Kubernetes, the atomics client libraries, and a new CLI, which I'll do a demo of. So if you like, under the atomics organization in GitHub, there's a bunch of new projects. Basically, yeah, like the Java client API, which is the protobuf API specs. Go client, all these projects are new projects that that are sort of like a disaggregation of the old atomics project. And so the purpose of the atomics Kubernetes controller is to basically support deployment of atomics in Kubernetes. And the way that it's done is it's sort of implemented as a custom operator. So what an operator is in Kubernetes is something that basically adds a custom Kubernetes resource, which I'll do a demo of and explain that a little more. Basically adds custom types to the Kubernetes API that handle deployment of specific types of objects. And so in the case of atomics, what we're, the sort of primitive that we're working with is partitions, right? So typically we deploy a bunch of partitions that implement some protocol, like, and so the purpose of the atomics Kubernetes controller is to basically interact with Kubernetes to tell it how to deploy wrap partitions. So I'll show an example of that. But this is sort of what the sort of interaction looks like. And there's lots of good information in this README. This is what the sort of interaction looks like between the client, the Kubernetes controller, which is this project, and actual deployment. So the client, I mean, basically the purpose of the controller is for the client to interact with the controller, tell it to, hey, I want to deploy some RAF partitions. The Kubernetes controller understands the Kubernetes API, tells Kubernetes how to deploy the RAF partition groups, and Kubernetes handles the deployment. So to do a quick demo of this, one of the requirements of basically using the controller is just that you deploy the controller, and I'll show you what it looks like. So there's a sort of a manifest for the controller. Basically, what this does is deploys this pod inside the kube system namespaces, which is where all the other controllers live. And if you look at the logs for the controller, you'll see that there's a partition controller and a partition group controller. So what this controller adds is two new resources to Kubernetes. And so one of the resources is called a partition group, which basically defines a set of partitions. And then one of the resources is a partition, which is, it defines basically a RAF cluster. So so what this allows is something really cool. So in order to basically deploy a RAF or a set of RAF partitions, then all you have to do is define a partition group resource. Let me show you what that looks like. So this is a file that I've defined to deploy a set of RAF partitions. So basically, this tells Kubernetes deploy a partition group that implements the RAF protocol with 3 partitions, with 3 nodes in each partition, and then gives a configuration for RAF itself. And so if you do, if you tell Kubernetes to create that, what you'll see is, like, if you do get partition groups, you'll see that there's RAF partition group created. Get partitions. The controller created 3 partitions, like I told it to here. And then what happens with those partitions is all the Kubernetes, all the standard Kubernetes resources you'd expect get created to actually run the RAF protocol, run several partitions. So like, if you do get pods, you'll see 3 pods for each partition. So there's the RAF 1 partition, the RAF 2 partition, the RAF 3 partition. You'll see services. So there's a normal service and a headless service for each partition, which the headless service is used internally to form the cluster. This is something that's required for, just because of the way that strongly consistent protocols work. And you'll see configurations for each partition and things like that. So that's basically the way that the Kubernetes controller works internally. And then the idea is that, well, I mean, each of these partitions obviously is used to manage or to replicate distributed primitives. And so the next thing that I wanted to do was find a good way to test them. And so I actually, just by accident, started working on the CLI just because I wanted a way to test this thing. So actually, clean this up a little bit. So I created this this Atomics CLI. So there's a little demo on the README that you can look at. But basically, this uses the same framework that is used by Kubernetes and Docker. It's called, well, there are 2 frameworks. There's Cobra and Viper. Cobra is like the command line parsing and command library, and then Viper handles persisting configurations. And it actually my first iteration at this, I basically used like the built-in flag package from Go, and it doesn't support like nested commands and things like that. But Cobra and Viper were way more powerful, and I'll show a demo of that. So what I did with this CLI is I actually made a Docker image that has the CLI installed on it, so that I can just deploy it in Kubernetes and use the CLI. And so this is what the command to actually deploy the CLI inside Kubernetes looks like. So it gives a bunch of commands, like for, well, configuring the client, configuring the controller. So the idea is that the client, or in this case the CLI, can interact with the controller, in this case the Kubernetes controller, to learn about which partitions exist in the cluster and understand how to connect to them, since they're all running in different pods like that. And then there are a bunch of, oh yeah, and then there's group commands, which these are for managing partition groups, which I'll show you, and then a bunch of primitive commands. So if you do like, so this connects basically to the default path for the Kubernetes controller. And then with that, you can see the partition groups. I deleted the other partitions, so they're not shown here, but you can also use the CLI to create partitions. I just created some RAF partitions, again, 3 partitions. And so if I go back to Kubernetes again, I should see the RAF partitions created again. And then from there, you can, like with the CLI, say, use the RAF partition group, and then you can create primitives. So create a counter. Didn't work. Of course it didn't. Oh, the partitions are still starting. I forgot about that. Take them out. Yeah, so they're not ready yet. They're starting to get ready. Yeah, so obviously the RAF, each of these partitions is essentially an independent RAF cluster, and they're all forming with each other and electing leaders and things like that. All right, so yeah, so now it should go. I have no idea why this is happening.
It's Murphy.
Yeah, I know, it's crazy. Totally crazy. Yes, real quick. There you go. Yeah, it's something with the state of that CLI after I tried to use it too soon. Yeah, so I can like add an entry to a map primitive. Get, yeah, so I created a key foo with value hello world at index 7, got that entry, and then I'm sure counter will work now also. And this actually has completion, which is really cool. The Cobra library has good support for generating bash completions, and then I actually stole some code from the Kubernetes code base to do Z shell completion from the bash completion. So yeah, this supports completion for most of the commands. Yeah, and you can do this through all the primitives. I won't go through all the primitives, but that's basically the demo of the CLI. And so the idea is that I think in the case of, let me go to the, like again, like last time I was showing the Helm charts from the ONOS config project. The cool thing about the way that the Atomics Kubernetes controller is structured is when we want to modify this Helm chart to say that we need a database, all you have to do is basically define something like what I showed a minute ago. Like we can just add, basically to say that we want RAF partitions, we can actually add this type of object to the Helm chart to say, basically create some RAF partitions for use in the ONOS config project, or that could be shared across multiple services or whatever.
It's basically a first-class citizen of the Kubernetes resources, right?
Yep. Yeah, and so you can so you can see these in the Kubernetes CLI, I mean the Kubernetes UI and things like that also. The partitions that have been created and things like that.
This is great.
That's all I have.
This is awesome. So why don't I go next? This is basically just going to be continuation of the same stuff. Shamelessly borrowed the approach for the CLI from Jordan's for ONOS config. So here, let me present. All right. So I have just a running simple. No. So I have basically running server in the background, and here I have ONOS CLI, which very similarly uses the Cobra to what Atomic says. It uses the Cobra and Viper combination to be able to interpret CLIs hierarchically. I've already have the completion loaded into my shell, but for those that needed to, for example, if you wanted to load the completion, all you need to do is eval ONOS. And this will prime it with the auto completion rule. So for example, I can say ONOS devices list -v, and this will show you all of the devices that are currently in a device inventory under the for the ONOS config. I can add devices, we can remove devices, we can list network changes. We can list the individual configurations. Unfortunately, I don't remember what. Oh, no, that's not the config. Sorry. But
device one, Thomas, capital D.
That's what I was missing. Just what is the parameter? Do you remember offhand? This is device.
Device name, is it? Oh well, the name of it is capital D, device one.
Like so.
Yeah, like so. Yeah. You can take off the
something.
Yeah, exactly. Take off the base 64 bit. I don't know.
This is me. I was just going through the various commands. I'm not familiar with the usage of the config command, but you get the gist basically, that it supports all of these various usages, including rollback, ability to be able to view the device tree configuration in a tree format, and so forth. So this is just a first take at it. It has the auto completion in there. Currently, this is not documented yet on the READMEs. That's something that I'll be working on today. And again, this is just a first pass. Presently, the CLI implementation is co-resident with the ONOS config source tree, but I think I would like to move it out to its own repository, so that basically the ONOS config will span all of the 3 different subsystems, and we basically have an integrated usage for ONOS as a whole. But again, this is something we can discuss at a later time. For right now, it will continue to reside here. This is intended to replace the existing individual commands that we have under the source tree. If we were to look at the, we have, for example, the diags command that has 3 different subcommands there. All of these will eventually get, and what I mean eventually, probably soon, will get removed, because they're all replaced by this consolidated CLI. But I wanted to wait until all of the until the documentation is available, and until all of the collateral for testing it and for igniting in a Kubernetes cluster and in Helm charts were properly updated to reflect the new commands. And that's basically it. Similarly to what Jordan did for the Atomic CLI Docker container, that's actually currently work in progress, but I'm just hitting some bumps in a ONOS in the Makefile build but it should hopefully get resolved sometimes today. So that will be available shortly as well. So we'll be producing effectively two Docker images, one for the CLI and one for the ONOS config server.
Yep. And one for the device emitter.
And one for the device emitter, yes. So that's all I had.
Hey, Thomas,
Yeah.
do you think the intent is to eventually move this into a separate project that it can work with every service?
Yeah, would you have one CLI to control atomics and ONOS, for example?
Well, I mean, for ONOS config and topology or whatever else.
Right.
Whatever else.
Yes, for all of the 3 or 4 different subsystems that we'll have: ONOS topology, ONOS config, ONOS control, and potentially ONOS RAN. I would like to have all of those.
Yep.
Now, there is an argument to be made that each of those separate should have their own usages, and we can certainly talk about that. I was thinking that it would be good to have one across all of them.
I agree.
Discuss.
I agree with that. I think there is value in having one, and in just listing the possible commands. Like, let's say you deploy it with topology, config, and control. You can do all of them. You deploy it with just one. You can do just some of them. And either we return an error when you try it, or either we don't even, like, let's say, autocomplete. But we can discuss this.
Yeah, we'll need to discuss it because there's definitely pros and cons for either approach. So, but anyway, that's all I had. What next was on the list here? Is it okay? So, Andrea, did you want to do the Stratum integration demo?
Sure, I can do that. Let me take the presenting screen. Can you guys see my screen? Is it big enough?
Yep.
Okay. So what I'm doing here is I'm running a Docker image that exposes 3 instances of Stratum. This was built thanks to Carmelo out of the Stratum project. And basically starts minute topology unlinear with unlinear topology. So fairly simply, it starts it. It adds a few switches, a few hosts, and this is the simple minute prompt. Here, what I'm doing is I'm tailing the Stratum log of the first one, the S1, and just because I need to remind everybody to mention it and use it later, this actually does use BMV2 as a backend to Stratum, and so there are some GNMI things which are not supported. So basically what will happen is that I will push a configuration and we will see it traveling through the Stratum code, but stopping when it hits the BMV2 code. I hope we can fix this at some point. And this is just an initial integration that we did since like a few days. So I think it has value nonetheless, because we're going to see it hitting the BMV2 code and just returning. I cannot do this at the moment. So here I'm starting ONOS config with Stratum Devices. Basically, what I'm doing here is I'm getting the capabilities of the Stratum device. Sorry, not the capabilities, the whole config tree of the Stratum device. It's everything it can give me. It's just I'm not intending to print this every time. I'm just showing it for the benefit of knowledge. Here, I'm just showing everybody that we have 3 devices with their ports. And then what I'm doing here is I'm actually setting the value of S1 ETH1 port to false. Here. No, sorry. Wrong folder. So this creates a configuration change in ONOS config that does an update on the port with value false. And what we can see is that if we go into Stratum, we can see that Stratum actually does remove the port with the chassis manager. That means that the request hit the GNMI code in Stratum, hit the GNMI code, went through it, and actually did what it was intended. But then the BMV2 soft switch does not have the set value implemented yet inside it. So we're not going to see the difference in the port status. But let's say we put it on a device that does support the set inside the hardware device, we will see that change. And within ONOS config, we scroll to the bottom, we will see that we got a set response from Stratum itself, and this is the change that we have. So yeah, this is doing what is expected. The next steps are to get the capabilities. There's actually a patch from E on the Stratum repo to do it. And we also merged on Stratum a few deviations to the Yang model in order to show in the capabilities exactly what Stratum supports. So the next step is to actually subscribe to all those paths that are supported and get the changes, and get the changes when they happen. So yeah, this is it. Thanks Carmelo and the Stratton team to putting up the Docker image. I think it's pretty cool, and we should keep that updated with the new changes as soon as they come in. That's all from my side. Thanks.
Thank you, Andrea. This is great.
By the way, I didn't ask any questions.
Doesn't sound like it.
Okay,
Thank
great.
you. Nice job. Okay, Adib, you ready?
What else, Sean? I'm ready, but Sean, if has to present, I'm ready. That's fine.
Sean, did you have stuff to present on the validation stuff?
You can go ahead there, Adib.
All right.
Okay.
Okay. Can you see my screen? Okay, great.
Yes.
So, to give you an update for those who are not in our ONOS stand meeting, we completely moved the.
One second.
Okay. We completely moved the GNMIs, the simulator to its own repository. So and currently it's in a separate repository. You can build it, and there are some if you think that we need to decide where to put those stuff related to Kubernetes stuff, deployment files. So in the last 2 weeks, I was working on implementing of the subscribe stream for the GNMI simulator. And what we have now is an early implementation of subscriber stream, because it doesn't use YGOT to generate the output based on the IETF JSON. So if we would like to have that one, we need to use YGOT. So this is an early implementation. I implemented just for the testing purposes. And to show you a demo, there is here on the right side, there is a subscribe client running. It's subscribed to a stream. And the idea is that whenever there is a change, so we would like to stream the events to the client. So the current value of the time zone name is Europe, Spain. And if I run a set command, so it will be changed to Italy. So it means that there is a change in the config, and that change will be streamed to the client. That's the whole idea of the stream. So a stream has 3 modes. One of the most important modes is that whenever there is a change, we will stream the changes to the client. I also implemented a feature just for the testing purposes, and the idea is that we would like to generate a random event that for example, every 5 seconds, its value will be changed, and we would like to stream this event to a client. So this is used just for the testing purposes of ONOS config to change a state variable in the ONOS config. So to show you that, so we define a predefined path. It's an IP address. Every 5 seconds, I'm changing the IP to generate a random event, and this random event will be sent to the client. So that is just for the testing purposes. It's not part of the GNMI specification, and it's just used for the testing of the writing the state variable in the ONOS conf. So that's my demo and that's my status.
Cool. That's great. Thanks, Adib.
Thanks.
Sean, I know you started to work on the WiGod validation. Do you have some stuff to share with as part of the update, or do you want to wait till next time?
Yeah, I can give a quick update. There's, let me just do this. So this is, let me see. So WiGod, as most of you know, is a tool for taking in Yang models and building a Go object model out of it. And so what we wanted to do is be able to validate inputs on GNMI against the Yang files. So WiGod is really the tool for it. But what we wanted to do as well is be able to dynamically load in Yang files and models. So what we came up with was a system of plugins. So we have the main ONOS config application, and what I've done here is I've created a plugin which is basically effectively a shared object library per type of device you're going to be dealing with. So here I have 2 different versions of this same device type, test device, and I have a shared object library for each one. So in future, you know, Stratum version 1 would have its own model plugin. Stratum version 2 would have its own model plugin, and really it's driven by the Yang files effectively. So inside it, I have, like, you know, a definition of what Yang files are included in this version of the plugin. So this one is the 2018 20th of February version, and here, for instance, with this newer one, it's the 2019 version of the same test file. So when I run the ONOS config now, basically, let me just bring up the command. What I have is I have a flag on it, so that you can specify any number of model plugins that you want. So if you wanted to support Stratum, basically you would add in the Stratum plugin. So I'm going to run this ONOS config here, and really just, I suppose, to prove the point, then really I'm showing here that I have loaded the model plugin, and it was dynamically loaded as a shared object library. And what I'm working on actually is that you would be able to add these in runtime, you know, using a particular RPC for it as well, so that you'd be able to, in a live system, unload and load models dynamically. And also it allows people outside the project, as long as they follow the template, to build their own model plugins without modifying the code. So what I had as an example is I had a GNMI set command here, and what I was trying to do is set this leaf2a value to 15, and in fact through the Yang file I had restricted the range that it could only be 13 as the maximum number. So basically what I do now, when I do the set, I get a response back that says it gives me the path leaf2a unsigned integer value 15 is outside the specified range for schema, you know, leaf2a. So this is part of the idea, is that you're using the Yang file to drive validation of the model internally, and you know, it can be used in many different ways. So I think it's an important step in bringing in validation and quality control into the configuration system. And the whole idea here is that, you know, when you take something like Stratum, that you want to accurately have a picture of what the device can support and what it can't support, and so that you don't push the errors, you know, that you don't constantly push config down to Stratum, that Stratum is just going to tell you, sorry, I can't accept that value because I don't support changing that attribute. What you want to have is the validation as much to the front end as possible. And so then if you, in future, want to use a CLI to do your configuration or a GUI, the GUI can be driven by the Yang, and so it's an accurate reflection of what the system can actually do for you. So, so that's it. Any questions on this?
I don't have a question, but just a comment that this is excellent.
Good, thank you, Thomas.
I think we were talking about Monday, how we're going to do this, and you already have it done.
Yep. I was just thinking the same thing. Wasn't it over the weekend we were deciding, well, we're going to use YGOT? That's all.
Nicely done.
Good.
Any other questions? If not, I think that kind of constitutes the update. Now, logistically, I think we had a milestone set up for this presentation. We can most likely we're most likely going to set up another one sometimes tomorrow for 2 weeks from now, so that we can kind of know where we're aiming at, and everybody is welcome to keep abreast of the progress on our GitHub issues and projects boards. And by all means, please feel free to jump in and help out. There's a lot of work to be done. Unless there's any other questions, I think we can call it a day today. Going once? All right. We'll see you in 2 weeks. Great. Thanks a lot. Great job, everybody.
Thanks, everybody. Take care. Bye-bye.
Bye.
Thanks, bye-bye.
Bye.
Bye.